Erwin Schrodinger was born on August 12, 1887, in Vienna, Austria. His father was a botanist, and his mother was the daughter of a chemistry professor, so he grew up immersed in the sciences and always held philosophy in very high esteem. He was also fluent in English, as his grandmother was from Britain. Throughout his life, he worked as a theoretical physicist at many different universities, including the University of Berlin, where he was a contemporary of Albert Einstein and many other prominent physicists, whose theories served as inspiration for his work in quantum physics. He won the Nobel Prize for Quantum Mechanics in 1933, along with Paul A.M. Dirac. Schrödinger's cat was a thought experiment devised to explain the theory of quantum superimposition. This is the idea that something, a quantum system, or in this case, a cat, can exist in many different states simultaneously until outside observation forces it to conform to a single reality. In this experiment, you imagine a box. In the box is a cat, and with the cat is something, in the original experiment, a bottle of poison, which is equally likely to kill the cat or not. You, as the outside observer, don't know whether the cat is alive or dead, and so the cat exists as both at the same time until you open the box and force reality to conform to one outcome or another. It's a little bit like if a tree falls in the forest and no one is around to hear it, does it make a sound? If you were to apply that to Schrödinger's cat, the tree both would and wouldn't make a sound at the same time. By far, Schrödinger's most important contribution to the scientific community is his creation of the wave function. While other scientists before him had been able to describe the behavior of the hydrogen atom, Schrödinger's equation describes the movement of all atoms in existence, and proposes the idea that electrons can function as both particles and waves at the same time, an idea that has become central to physics today. Basically, a hydrogen atom only has one electron, so the relationship is pretty much 1-to-1. But when you expand into larger atoms, additional electrons form a field. A field is a finite space made up of an infinite number of connected points, like the surface of water. We've all seen how waves form in water, and what Schrödinger's equation does is show how to predict the movements of electrons like we can predict the movements of waves. Schrödinger's equation is truly the basis of modern quantum mechanics. It has even made possible things like the Large Hadron Collider and string theory. It has fundamentally changed the way that we think about the particles that make up our universe. And as scientists continue to expand into the field of quantum mechanics, they have Schrödinger to thank for the possibility to move forward.